Right, let's wait for YouTube. It usually takes about a million years before YouTube starts playing the guitar on the MTV. Let's wait. We need to wait. Anyway, so today, what I thought to do in this video, I just wanted to find out exactly what was Einstein's, oh, hello, hello. What was Einstein's motivation? Yeah, I'm waiting for YouTube to confirm that we're live. Sometimes it takes a long time, long time. Anyway, so I wanted to go over some videos. El Mano, what's up? Oh my God, come on. So I wanted to go over some videos of the YouTubers. Why did Einstein? Yeah, Elmano, don't do that. Come on, don't ruin the stream. So why did Einstein think that or assume that the speed of light is a constant for all observers in an inertial frame of reference? So anyone who's not accelerating is measuring a constant speed of light. I wanted to explain it, but YouTube is not cooperating. Wait, maybe I'll refresh it. Sometimes it helps. So we've been live for 2 minutes almost. Oh, but my mic is no good. You see, that's the reason. That's the reason. Okay, let's wait now. That's the reason I wait for YouTube. So Elmano is saying he didn't assume it was an intolerance or deduction. I don't know what is entailing. Oh, entailing. Oh, mic is so bad now. Well, my mic is better now, I think, than it was before. It's clearer. Anyway, let's begin. It was better before? No way. It was echoing in the room. It was the laptop mic instead of the headset mic. I think it's better now. Yeah, yeah. From the live perspective. Oh, maybe from the live perspective. No, I'm listening. I can hear the beginning. Let me hear the beginning. Oh, the beginning was good. No, no, no. I'm listening to a different video. Sorry. Shabi. One second. Let me check. Let me check. No, it's the mic. It's the laptop mic. It's terrible. It's not going to be. Forget it. Look, Elmano. Oh, do you want? You know what, Elmano? Elmano. Do you want to join me in the stream? You can join if you want. You're welcome to join. Here's the link. We're not going to be using Discord today because Discord doesn't allow streaming through Discord. Discord is too good for us. All right, let's begin. Let's begin. Let's begin listening to this guy. He's one of my favorite physics YouTubers.
When I first wondered about how Einstein discovered relativity.
So, why is speed of light the same c in all frames? An intuitive explanation. I really want to know why Einstein thought it would be, not why. What's it? I don't even know his name. Maesh. Maesh. So let's hear Maesh.
I came across his famous thought experiment, the one where Einstein imagined himself moving at the speed of light and switching on his flashlight and wondering, would he see light to be at rest? And somehow this led him to the theory of relativity. And at first I was like, wow, what a mind boggling experiment.
Okay, I don't know why. Wow, I don't know. I don't know. I mean, it's pretty straightforward, no?
But then I thought, wait a second. What's the problem if you see light to be at rest? I mean,
Because I was always thinking that light is a wave, and as a wave, so it's a problem because if I'm traveling in water and I go at the speed of the wave, then I'm not. That's how that. Okay, so that's a good question. So we need to discuss this. So we need to discuss it. Let's share. Let's share Discord and let's. This is a good question. Where is it? Here it is. Whiteboard. Lublubum. Lublubum. All right. Let's. Okay, this is the previous lesson. Uh, we can continue, I guess, in this one. So let's magnify it. Let's move it up a little bit. All right. So, what is the issue? The issue is what if the observer, what if I am traveling at, right? So we compared the speed of light in our reality to the speed of, let's say, sound in a water tank. So if I was in a water tank, let's draw a picture. So let's imagine a water tank. Let's assume this is filled with water. There is a water tank. I'm immersed in the water tank, and let's say, okay. So what are we comparing it to? So what happens? The thought experiment Einstein was thinking is the person. I am the person. This is the person. This is me, and I am in a car. Let me move this up a little bit. So I'm in a car and I'm moving at the speed of light, c, and I have, let's say I have a candle. I'm holding a candle because this is this is just the beginning of the 20th century. So I'm holding a candle, but I'm traveling at the speed of light. So let's put maybe a glass so the wind doesn't blow. So there's glass, but I'm traveling at the speed of light. And the candle is in front of my face. What would I see? That's a good question. What would I see? I mean, I'm trying to think. I mean, you're going to see the candle in your face. Like what he's asking is usually the candle, let's say he puts that I put a mirror, there's a mirror on the candle. So it's like a flashlight. So usually I can see a little bit ahead. Let's say it's a good candle. So, and by the way, here's the road. So 1 second, let's make this make a little bit more sense. So here's the road. Here's the road. So because of the mirror, I'm able to see this area. Usually light reflects off of it, so I can see very well ahead using the candle. But this is normal speed or stationary. But as I move faster and faster, closer to the speed of light, so what happens? Good question. So let's imagine, let's compare it to the water pool, to the water tank. So let's go into a water tank and run a similar experiment. So I'm inside a water tank, and here is me, and I'm going to make a sound. So I'm going to just make a sound. And usually I'm going to use a sonar. So sonar, so you make a sound and the sound comes out as waves. So it's going to come out as waves. And it hits, let's say I'm waiting for it to hit somewhere here. And this is where I pick up the waves, the sound from this direction. I have um, like a dish. I have a sound dish that absorbs only from here. Only sounds from here will be received, will be detected. All right, so this is a normal submarine or any other sonar. I think that's how it works. Something like this. Okay, but this is as long as I'm not moving. So as long as I'm not moving, the speed of sound is, let's say it's also c, and it's about 300 meters per second. It's 1,000 times slower than light. Fine. All right. So the speed of at the speed of sound, boop boop, it comes back really fast. So it's tick 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 tick, really fast. But now let's say that I am traveling faster and faster, closer and closer to c, to the speed of sound. I'm traveling closer and closer to the speed of sound c. So at the speed of sound, the waves cannot travel. It becomes impossible for the wave to travel. The wave is trying to get out, but it can't. Because, I mean, it can, the wave is traveling, but I'm moving forward with it. So in such a case, right, so let's say the wave from just a few seconds ago, just for, not seconds, but just a few moments ago, a few microseconds ago, my head was here, but now my head or my sonar beeper is here. So the next wave is going to be, it's going to form this. So the waves end up forming a wavefront. If I travel exactly at the speed of sound, all the waves are going to look like this. They're not going to move forward relative to me. That's what we'd expect, right? That's normal wave behavior. So the question is, let's not get lost. How does light behave? So light should do the same thing. But Einstein said no. Not only did Einstein say no, but we know that from the Michael Morley experiment, light is observed always at a constant speed. There's no way to measure light at any different speed. They expected exactly this effect. This is what Michelson and Morley expected. They didn't get it. No matter how they turned the table, and I still owe you a discussion of the exact experiment. Maybe we'll do that later today. So, but the Michelson-Morley experiment said no about light. This is how it always shines forwards. You never, even at the speed of light, even if you travel at the speed of light, very close, 99.999% of speed of light, you're going to be shining the light forward and it's going to come back to you. You're not going to notice a difference. That's what Michelson-Morley found out. So Einstein said, let's assume the speed of light is a constant. Okay, and then he changed everything, but he abandoned the ether. He abandoned the medium through which light travels, which is as far as I'm concerned, that's unscientific, because now your system makes no sense. Your proposition makes no sense. Your scientific theory is no longer scientific. What do you mean a wave travels in nothing? That doesn't make any sense. A wave, as far as we know, travels through a medium. hmm So Einstein, I think, is unscientific. Nevertheless, I'm curious what drove him to assume the speed of light is a constant. I can assume the speed of light is a constant because I'm assuming light is a wave, and I have an explanation for why I would still perceive the Michelson-Morley experiment, even though light is a wave waving through the ether. There is no issue with that, and I can explain it. Hopefully, we'll do it later. Okay, nevertheless, let us look at the video. We started watching a video. Let's go back to the video and hear Manesh, I think. Mahesh. Let's hear him. So let's share and let's continue.
I mean, if I travel at the speed of sound and planes can do that, then I see sound to be at rest. And if I swim at the speed of water waves and ducks can do that, then I would see water waves to be at rest. We don't have a problem there, so what's the problem with light? That's where I realized that there was something deeper going on over there, and I had to connect a few more dots. But finally, once I did it, then my mind was truly blown. And therefore,
This guy always gets his mind blown. I never get my mind blown. I don't know why he always gets his mind blown. I don't understand it. What? I get my mind blown when I figure something out. I don't get my mind blown so much in any other situation. I don't know. He's a fanboy. He's like a physics fanboy. He's always explaining science. He's never questioning. He's never rethinking. No one does. Everyone just retells the story, the truth from the gods, from the Einstein and the Planck. Everyone was correct. Let's hear from the gods. I don't work that way. I mean, I question everyone, everything. Of course, I question myself. I question every source of information all the time. And I re-question and re-question, and even when things are obvious and clear, I'm still open to start from the beginning, as difficult as it is. Getting your mind blown is you're like you're behaving like you're brainwashed. I don't think it's a good. You should avoid. I would say you should avoid doing that. Nothing should blow your mind. You should always be skeptical. I mean, in my opinion, in my experience, you accomplish more by just being skeptical. All right, let's continue.
the goal of this video is not just to understand relativity, but to actually
And he's always so happy. It's like he's literally acting like a cult member. It's like in a cult, you smile all the time. Like, no, these people are really happy, but it's very reminiscent of a cult. So, yeah, that's all I got to say. I'm just saying.
do a series of thought experiments, all the necessary thought experiments to truly understand how we discovered relativity. And so, if you show some patience and follow along, by the end of this video, you
And he said we discovered relativity, as if relativity is some truth. Hmm. Maybe it's because I'm beginning to question relativity that I'm noticing this.
would have a much deeper understanding of what went on in Einstein's brain. And so, if you're
Yeah, it's like let's worship Einstein while we're at it.
ready for this, let's begin. So, where do we start? Well, let's ask Einstein. Einstein, where do we start? Einstein uses an overview and says that if we combine our ideas of inertia and Newtonian relativity, the relativity that we already knew about, with electromagnetic waves, then there's only one logical conclusion: special relativity. And that's what we need to understand. And therefore, we need to start with the
Did Einstein really say this in his paper? Did he really mention Newtonian relativity and electromagnetic waves? I'm curious. Let me see. I have a message. I cannot take the call. Let me just tell them that I cannot take the call. 1 second. 1 second. The palace. 1 second. The palace. All right. Let us continue.
basics, understand some consequences of inertia and Newtonian relativity.
1 second. Let me see the message. Where's the message? Oh, okay. Everything is fine.
So here's Einstein in an open car coming towards me. But Einstein says, hey, Mahesh, that's your point of view. From my perspective, my car is at rest and you and the road are moving towards me. And I tell Einstein, well, yeah, but that's an illusion. You see, it's your car that's really moving. But since you are also moving along with your car at the same speed,
I'm not. I'm just. I don't know. Some people cannot say V. I think Indians in general have a hard time saying V. It's really weird. the way the brain works, how I think like at age, I would say at around 10, 9, the brain shuts down its ability to learn like different language pronunciations. Then, if you learn after that, you're going to have an accent. If you learn before that, you're not going to have an accent. It's really strange. It's really strange. Something happens in the brains. There's some shift. Something happens. Very interesting.
You get an illusion that you are at rest, but in reality you and your car is moving. And Einstein says, well, Mahesh, I can say the same thing about you. Your ground is really moving, and since you are also traveling at the same speed along with the ground, you are the one that gets the illusion that you are at rest.
Wait, let me check the audio. Is the audio still good? 1 second. Let me check. Yeah, the audio is good. All right, it's fine. I just hope he doesn't give us a strike.
But in reality you are moving. So how do we solve this? It sounds silly, but how do we solve for this? Well, Einstein says we need to identify an experiment that he can do that will confirm that indeed it is him that is moving. And I say, well, very simple. Einstein, your car is shaking. And if you're traveling on Indian roads, you know you're moving. And I
It's not just Indian roads. Roads all over the world today belong to the government. So, what do you expect things that the government manages? What do you expect them to look like? So, roads are just, people say if we lived in a private society, who would build the roads? Well, at the end of the day, it's the private contractors that build the roads for government. But the government has very few jobs to do. One of them is to maintain the roads, and it does such a terrible job. I mean, it takes so much in taxes. The little it needs to do is maintain the roads, and everywhere around the world, the roads are in horrendous shape. There's no place on earth I've been around. No place on earth I can tell you. Finally, the roads are better than absolute doggy shite. So yeah,
Einstein says for the rest of the video, Mahesh will only consider very special cases
Mahesh. His name is Mahesh.
where things are going at
Why does he have that thing on his head all the time? Usually Indians have hair.
constant velocity, no shaking, no accelerations whatsoever. And I ask Einstein, but why? Because Einstein says this is a video on special theory of relativity. Wait, is that where the word special comes from? That's right. The word special comes from the fact that Einstein, when he was initially thinking about it, he only worried about constant velocity motion. So that's what makes it special. We're only considering special cases where things are moving at constant velocity. Later on, he found a way to extend this argument in general to all kinds of motion.
It's really interesting that Einstein did have this separation between special. He didn't call it inertial. Like he should call it inertial relativity and acceleration relativity. But it's really strange that he made this separation because it took him 10 years to figure out the acceleration relativity.
General relativity. Okay. All right. So Einstein is coming towards us at constant velocity. How do we confirm that it's him that is moving? What kind of an experiment can we do? Actually, quite simple. Einstein, take a ball, throw it up. See, what I'm thinking is if he throws up a ball, then because his car is moving forward, that ball is going to fall behind him.
I just remember doing this test while I was on a train when I was really young. And I honestly expect, like, really, I think I did this like at 4 or 5. I don't know, maybe even before. I just remembered. Like, I threw up the coin. I really expected it to fall behind. I was in a train, I think. It was like, it was so it was so convenient to run this experiment, and I ran the experiment, and I saw I think this is Galilean relativity.
And so, from his perspective, it will feel like the ball went back. And we're ignoring wind over here. So, if you were at rest, the ball wouldn't go back. And that's how we would know that Einstein is moving. So, Einstein, let's do that experiment. So, he does that experiment and it doesn't work. The ball comes back to his hand. Why did that happen? Einstein says we forgot something. See, even before the ball was thrown up, it is in motion. It has a forward velocity. And so when it gets thrown up, it continues to move forward because of inertia. Newton's first law, things at motion have a natural tendency to stay in motion. And therefore, as that ball goes up, look, it continues to go forward, and therefore it'll always be directly above Einstein's hand, and therefore it lands back on Einstein's hand. And so, because of inertia, Einstein gets the same result as you would get on a ground, confirming that he's at rest. Okay, Einstein, but I have another experiment. This time, Einstein, imagine you're holding a gun, a toy gun, not a real gun. YouTube, don't censor this, don't ban this. Toy gun with toy bullets. Okay, and imagine your car is going at the speed of that bullet. Now, what's going to happen when you shoot that bullet? Well, the bullet comes out at the same speed, and therefore the bullet and your car will go at the same speed, and you see that bullet frozen from your perspective, and that cannot happen if you are at rest. Therefore, you would know you are in motion. So Einstein says, let's do the experiment. Einstein does that experiment, and it doesn't work again. The bullet goes forward. Einstein says, again, I forgot about inertia. See, even before the bullet was shot, that bullet.
And by the way, this disproves. One second. This disproves. Okay. This disproves the theory that light is a particle, because if it were a particle, I'm not saying that it's like it's a real disproof, but this is a counter it's a counterfactual. So we know that light moves at a constant speed, and we know that under certain circumstances light seems to be a particle. But if light is a particle, why is it limited by the speed of light, right? If I move close to the speed of light relative to an observer, and I fire a bullet, a photon, meaning I shine a light forward with a candle, so that light should move at twice the speed of light, right? Let's say I travel at almost the speed of light and I shine a candle. The the outside observer should see the light of the candle traveling at or moving forward at twice the speed of light. The speed of light should not be constant if light is a bullet, is a particle. So that's I've discussed this issue several times.
Bullet was moving forward at the same speed as the car, so the speed of the bullet. And once the bullet gets shot, it will continue to have that same speed. But once the bullet gets shot, it will have an additional speed due to the gun. So this is due to this inertia, and then this is the additional speed because of which it goes ahead with twice the speed of the bullet, and that's why it goes ahead. And therefore, Einstein sees everything to be normal, confirming he is at rest. Okay, how about, and at this point, Einstein cuts off and says, Mahesh, in the spirit of time, let me tell you, there is no way you can do any experiment with particles to detect my motion. So Einstein is saying, look, any particle that you think of has inertia. And because of inertia, whatever experiment you do, regardless of how complicated it is, because of this inertia, Einstein will always get the same result as he would get when he's standing on the ground, confirming he's at rest. And therefore, he says we cannot use any particle to detect constant velocity motion. So what do? Well, particles have inertia, but what about waves, Einstein?
This is just going back to, I mean, the apple. There's no difference between the apple and the bullet.
You see, waves don't have inertia.
Particles, yeah, particles have inertia. So, wait. What was his point with the car? I don't get it.
To give you an example, let's here we have Einstein standing beside a string. Now, if Einstein makes a wave, that wave goes forward on the string. Now imagine Einstein is running at some speed and he makes the wave again on the string. What would be the speed of the wave this time? Would it change because Einstein was moving? No, the speed of the wave on the string depends on properties of the string. Like
That's good. So the speed of a wave does not depend on anything except for the medium.
how heavy it is, how tight it is, what is the material, and so many other things. It does not depend upon whether the source, Einstein, whether he's at rest or is moving. It doesn't matter. So even here, the wave will travel forward with the same speed. And since Einstein is also moving at the same speed, unlike the bullet, look, Einstein and the wave move together, which means it'll appear frozen for Einstein. So since waves don't have inertia, we can use waves to test it out. So let's do that. So this time, let's imagine Einstein's car is moving at the speed of sound. And Einstein makes some sound. He shouts it. That'll also travel at the speed of sound because just like with the string, this speed does not depend upon Einstein's motion. And now, for sure, both of these would travel together. So let's have a look at it. And that's exactly what happens. Both of them are.
Wait a minute. Is this with? So now there is air. So okay. So he's making a sound. They're moving at the same speed. It's difficult to tell because we should get like a cone shape out of the spheres that come out of his mouth. So I'm not sure what he's trying to do. That's not what you would see. The waves would come out more condensed.
Are traveling together, which means from Einstein's perspective, look, that wave is frozen. He will see sound frozen, but we know sound doesn't get frozen when you're at rest, confirming that Einstein is moving. What do you got to say about that, Einstein? And Einstein says, indeed, that's exactly what happens. But Einstein says, hold on, buddy, that doesn't mean I'm at motion. I'm still at rest. Wait, what? You just saw sound to be frozen. That doesn't happen when you're at rest. Einstein says,
I'm not sure what he means. So you're driving. I don't know what he means. I mean, the faster you go, at one point, you're gonna travel at the speed of sound, then faster than the speed of sound. You're not gonna, all the waves are gonna be behind you. I don't know what he's talking about. Oh, his point is that's how Einstein knows that he's traveling. Oh, yeah, you can tell that you're traveling. Yeah, if it's a wave, you can tell that you're traveling, sure.
Allow me to explain. He says, I am at rest, but there is a wind going backwards at the speed of sound. And air is going backwards at the speed of sound, and sound is trying to go forward in that air at the speed of sound forward, but because of the air, it's not able to go, and that's why it's frozen. So the reason the sound is frozen is not because I am moving, Mahesh. He's saying it's because there's a wind that's going backwards. That's what's making it frozen. It's very similar to have an escalator that goes up and somebody tries to go down at the same speed. He gets stuck in between,
Yes.
but that doesn't mean I am moving, right? That's a good.
So Einstein is saying that he is stationary, but there is a wind. There happens to be a wind. It's like he's in an escalator and the escalator is moving, but he's stationary. I don't know what he means with the escalator actually. Like, what it's difficult with all these analogies. I don't like the analogies. You have to stick to one analogy, and it's too many analogies. I don't know where you're going with all the analogies.
Point. Okay, what if we ignore the air? Well, Einstein said if you ignore the air, there is no sound waves. You need air for the sound waves. What
Oh, so you need air for the sound waves, but you don't need a medium for light. How interesting for light waves.
right? And Einstein cuts off and says, Mahesh, any wave you take, it requires a medium. And so Einstein says, whatever waves we use, even though waves don't have inertia,
Any wave you take, it requires a medium. Well, except for light for some reason.
all waves require some or the other kind of medium. And so when you're traveling through that medium, from my perspective, that medium is traveling backwards, giving me some kind of wind, and it's the escalator effect that's causing, that's making that wave to be at rest. That's causing that wave to be at rest. Not because I am moving, I'm still at rest. Which means you can't even use waves to detect motion because all waves require some kind of a medium. But Einstein even aspects over here. Why is because light does not require a medium? Is that what makes light special? And Einstein says,
That doesn't make any sense. That's an unscientific explanation. It doesn't make any sense. That's a dead end. That is a dead end. As soon as you say it's a wave that travels through nothing, you should stop the conversation and say, okay, that doesn't make any sense. Let's try something else.
yes, let's not jump to it. But the conclusion over here, the summary so far is that particles have inertia, so you can't use that to detect motion. Waves, almost all waves except for light, require a medium, and therefore they will have the escalator effect, and because of that, you can't detect motion. And since any experiment
What does he mean by the escalator effect? Oh, like the person is the wave. Okay. So the person is the wave, and the stream, the medium, is going that way. So you could have a standing wave in reference to an observer that's looking at the stream moving to the left, while the wave is moving to the right. The wave could be stationary relative, or even go backwards relative to an outside observer. Okay, that's the escalator effect. All right.
that you do would either involve particles or waves or a combination of them. There's no experiment you can do to detect constant velocity motion. So the only logical conclusion of this part is that
Well, particles, I cannot use particles to detect motion because, so if doesn't matter what speed I travel, I fire a bullet, it moves forward. So I cannot, there's no distinguishing. Like, the question is, how can a person know if he's moving or stationary? Yeah, I don't know. Yeah, there's just no way to know. I mean, as far as I know, there's no way to know. So I don't know where he's actually headed with this. Like, everyone can claim that they are stationary. So what's your point?
whatever Einstein said earlier, that it's him that is at rest and the rest of the world and I'm moving towards him, it's a perfectly valid viewpoint. It's not just an
He managed to confuse me, and I'm thinking around the clock about this, and he managed to confuse me. I don't even know where he's taking this thought experiment.
illusion. It doesn't. It's not that it appears. Einstein appears that his car is at rest. No, this car is at rest. It's a fact. It's as valid as me standing on the ground saying that I'm at rest and car is moving. Motion.
No, you could say that it has no meaning. If you don't have, like, if you don't say relative to, then saying at rest or moving has no meaning. It just doesn't mean anything. To say that I'm tall without saying relative to, that's meaningless. That doesn't have a meaning. It's undefined. To say that I'm short, fat, all these things have no meaning unless it's relative to. So yeah.
Is relative. This is what we call Newtonian relativity, which basically says that constant velocity motion cannot be detected. That's how our universe works. And
Wait, what do you mean? Galileo said this. This is Galileo's thought experiment about being at the bottom of a ship. So Why do you call it Newtonian relativity? Maybe Newton wrote the equations, and Galileo just told us about the thought experiment.
until we discovered that light is an electromagnetic wave.
That is a terrible, terrible, terrible cross section of a light wave. That is not what a light wave looks like. A light wave is a it's a sphere. It's a sphere. So what you're showing me here is a cross section of part of the sphere, not the entire sphere. Like if you would show me the entire sphere, it would be like, well, show me the entire sphere. This is not what a light wave looks like at all. It can never look like this. This is, as far as I'm concerned, can never look like this. Um, so yeah, I mean, and once you see what the magnetic part looks like, I mean, the magnetic is so bizarre. I mean, this entire thing is so bizarre. I wish someone would show an actual animation of the complete light wave. No one ever does. They always show this nonsensical. This you see this, you think this is a laser beam. This looks like a some focused, narrowly focused beam. This is not what happens. And the light has to, I mean, the intensity must go down because this is part of a sphere. So the energy of the wave gets diluted as it moves forward. So it has to tend to zero. Anyway, complete nonsense. It's such a shame in the 20, what are we, 21st century? You have so many simulations. You can't have a Maxwell equation simulator to show you what a normal, like a real light wave looks like? Terrible. Real shame. I mean, I would never show this. I mean, this is this doesn't tell you anything. This doesn't explain anything. It doesn't, it's like, what is going on here? This is really, anyway, let's continue.
See, for a long time, we thought light was a wave very similar to sound. It traveled through some kind of a medium. We believe that medium, we call it the ether.
Yeah, we used to think, yeah. The primitive ones, the ones from the before times, from the ancient ones, they used to believe it. We are so enlightened. How do you know there isn't anything there? How do you know? I mean, everything in physics says there is, except for there isn't. It's like, let's contradict ourselves more. I don't think there's a bigger contradiction in any, I would say, in any field in the world than light travels in a vacuum. Yeah, but this vacuum is seething with activity. Oh, wow, what a vacuum that is, seething with activity, that has energy and therefore probably has mass. Oh yeah, it's a vacuum with a mass and energy. Oh yeah, yeah, makes perfect sense. hmm Of course.
Medium, and we believe that E medium existed throughout the universe.
Yeah, and it's curved. I mean, of course, it's not curved. Of course, it flows, but they say it's curved. What is curved? Oh, the vacuum is curved. The vacuum is curved. Wow, that is some vacuum you got there that can curve. Wow, amazing. Makes a lot of sense. Very, very logical.
Universe. But fast forward to 1900s, because of James Clerk Maxwell and Faraday and a bunch of other folks, we realized that light is an electromagnetic wave. What's the specialty of electromagnetic waves? They don't need a medium. Electromagnetic waves can travel through space. At this point, Einstein asks us, Mahesh, do you understand the implication of this? And I say, yes.
Wait, who
Yes.
said he claims Maxwell said this? I'm gonna hear this again. Wait,
The whole reason waves can travel, other folks, we realize that light is an electromagnetic wave. What's the specialty of it?
what's the speciality? Jesus.
Second, that's how our universe works. Until we discovered that light is an electromagnetic wave. See, for a long time,
Oh my God, he smiles like. Oh my God, the way he smiles, like he's so happy.
thought light was a wave very similar to sound. It traveled through some kind of a medium. We believe that medium, we call it the ether medium, and we believe that E medium
Oh, the ether. The ether, I mean, we used to believe it. The ancient ones in the before times, the dummy dum dums. Yeah.
existed throughout the universe.
We no longer believe that. We only believe now that that vacuum, oh, it can bend. Oh, it has energy. Oh, it has mass. Oh, and it's seething with activity. Oh, it's a quantum foam. Oh, yeah, yeah, but it's totally a vacuum, though. Totally a vacuum. Yeah, yeah.
But fast forward to 1900s, because of James Clerk Maxwell and Faraday and a bunch of other folks, we realized that light is an electromagnetic wave. What's the specialty of electromagnetic waves? They don't need a medium. Electromagnetic waves
That is such nonsense. That is such nonsense. Because it's an electromagnetic wave, he's going to now tell us that the electric and the magnetic parts they help each other. They move each other forward. That even when you look at it, it doesn't make any sense. They're both high and low at the same time. The magnetic is moving to the right while the electric is moving up. How are they relevant to each other? And here they're both zero. I mean, obviously, there's some potential energy at this point because there's zero activity. So, where did all the activity go? I mean, it has to go somewhere. I mean, there has to be this. This is the compression wave, and this is the vacuum wave. And there's motion of particles. I mean, you can see it from here. There is particles moving. This is the motion of a particle. What do you think this is? This is some motion of some particles. Something is happening. You're straining. You're literally, you can see the tensor. You can see Einstein's tensor. You're straining. You're straining what Einstein called space. This is what is causing the curving and the bending. You can see it. And you call that a vacuum. Yeah, all right. You can call it whatever you want. I mean, you can call it a banana. I don't care. You call it a vacuum from the root word like to vacate, to evacuate. It's like to take. But everything you say says there is something there.
waves can travel through space. At this point, Einstein asks him, hey,
But what is space? Space has a mass. Space has energy. Space curves. Space is seething with activity. So what is it? Why do you call it like the word space and vacuum are opposite of what you're describing? Yeah, I gotta stop doing this. This is not for today. This is a different topic. Let me see. How much time have we been streaming? Oh, 42 minutes. Oh, we have somebody. Oh, look at this. Oh, sorry. Indian Eater's career is over. Chisma. Mr. Slava Claus, I am terrific, Mr. Slave Voice. Okay, but why don't you join me on the stream? It would be so terrific if we could join each other on the stream.
hey, do you understand the implication of this? And I say, yes, yes. The whole reason why we couldn't use waves to detect motion was because of the medium. It was giving you a wind and it was using the escalator effect. But light, if it doesn't travel through a medium, we can now that thought experiment makes sense. So let's do that. So this time, Einstein, you're
Oh my God, that is such nonsense. So you want to tell me Einstein relied on this nonsense? That is so sad. That is so unscientific. You might as well just bow down to the sculpture, to the deities. What do you call it? To the sculptures, to the idols. Just bow down to idols and pray to them, and you might as well at this point.
car is traveling at the speed of light and you're going to switch on the flashlight. We know that light is going to come out at that same speed, the speed of light c. It doesn't depend upon your motion. But what do you see from your perspective? From your perspective, light appears frozen. And now Einstein doesn't have any way to explain that. He can't say there's a wind because there is no medium. That's what makes light special. And therefore, now Einstein, you have no choice but to accept that you are the one that's traveling through space. Which means the fact that
I have no idea what he's saying. I don't know. Why would you expect this? Why would you expect this to behave in any way if you're saying it's a vacuum? I don't even know. Once you say it's a vacuum, nothing makes any sense to me. So I don't know. I don't know. But if your vacuum is as you said, it has an energy, low energy, and mass and everything, then it has a speed of light built into it, just like any medium. So this should be you should bump your head at the speed of light. You should bump your head against light. You should not be able to shine a flashlight forward if light is a wave.
light does not require a medium somehow breaks relativity. And Einstein
Oh
said,
my god, that is so dumb.
it's not just going at the speed of light. Even if you're traveling slower than the speed of light and you switch on the flashlight,
I can't believe I probably used to believe this not too long ago. This is like from maybe even 24 hours ago. Maybe I used to still believe it.
then we would see light going ahead of us, but much more slowly than the speed that Maxwell predicted. And so we would be able to detect any velocity motion. And therefore, if light does not travel through any medium, it travels through space, we don't get an escalator effect, and therefore we can detect motion. And so what does it mean? So light breaks Newtonian relativity. How do we solve for this? Einstein, how?
I don't understand. I have no idea what he's saying. Zero idea. I don't know whose side he's taking now. I don't know.
What happens next? Well, Einstein says most folks, our first instinct was to think that Maxwell screwed up somewhere. I mean, this can't be true. So a lot of us thought that no, light cannot travel.
Maxwell didn't discover that light travels through a vacuum. Light, I mean, they called it the permeability maybe of a vacuum or the permeability of space. I mean, they had two constants there that when you whatever take put them together into a one equation, into a wave equation, you get the speed of the wave as 300 million meters per second. So, um, so Maxwell wouldn't have said that there is no ether. I mean, it took everyone believed in the ether. I'm sure Maxwell believed in the ether, and only after Michelson and Morley, people started doubting the ether. And then came Einstein. He said, "Yeah, there's no ether," and everyone believed him. I don't know why, but Maxwell didn't think there was no ether. You're not getting your history right. I don't believe that's true. I mean, it was completely revolutionary when Einstein said it. I mean, that's the reason, one of the reasons they hold him so high is because he made no sense. It's like usually the geniuses are the ones that make less sense. Like if you're too mechanical, you can't be that smart. But if you say something that makes no sense, oh, you're a genius.
Travel through space because of this problem. Light must be traveling through that medium. Ether medium must definitely exist. In fact, people believe in ether medium so much that we thought let's do an experiment for it. See, Earth is traveling through space, and therefore,
Oh, I'm so confused. I don't know where he's taking this discussion.
just like in the case of Einstein in the car, if we shine light in the direction of Earth's motion, it should travel slightly. We should detect it to be slightly slower than the actual speed of light. And that way we could find the speed of the ether and the speed of Earth's motion and all of that. But when we did this experiment, in fact, Michelson and Morley tried to do this experiment, and when they did that, we found the speed of light to be exactly c, 300,000 kilometers per second, whatever was predicted by Maxwell. We didn't find any difference. In whichever direction we measured, we always found the speed of light to be exactly the same. What did it all mean? Einstein says this another experiment shows that there's nothing wrong with electromagnetism. Maxwell was good. So there's nothing wrong with electromagnetism, and we believe in Newtonian relativity. That cannot be broken. So there's only one way to put this all together. If light does indeed travel at the speed of light, and constant velocity motion should be undetectable, there's only one logical conclusion. The speed of light should be the same for all observers, even the ones traveling close to the speed of light.
But why? I mean, that's just Michelson and Morley. Michelson and Morley came to this conclusion. Einstein just took their experiment as a given, but he didn't give an explanation. There's nothing to get excited about. Einstein just assumed, you know what? Michelson and Morley gave us the result. So I'm not going to give an explanation why they got the result. I'm just going to assume the result. But he never came up with a theory. So Michelson and Morley's experiment never got a theory why they never got fine. The speed of light is a constant. No matter what you do, it's a constant. Fantastic. Why? That doesn't. You have to still answer the question. Why? What's the answer? Just to say the speed of light is a constant. That's not being a genius. That's just assuming not assuming the conclusion, but that's just the conclusion of the data. That's just the data that the experiment of Michelson and Morley gave us. So we have the experimental data, but now the experimental data contradicts the prediction that they made. They said, okay, let's predict that we're going to find a difference in the speed of light. They created this mechanism to get the speed of the ether, and they didn't get it. So their prediction was non-zero, and the answer was zero. So okay, you still need to explain the data. You can't just say, okay, we got the experiment wrong, and you can't do that's not science. So Einstein just assuming, and he never mentioned Michelson and Morley. He never said, you know what? I don't think he ever mentioned. Well, I don't think I don't think he has any references in his paper. Maybe he does. I don't know. But we anyway. I'm really curious what drove Einstein. Did he really just say, I'm gonna just assume the speed of light is a constant and have a great rest of your day? Is this what he did? Or did he have some theory to back it up? Because I have a theory. At least I have a theory. What am I the? I'm going to be the first person to explain the Michelson-Morley experiment because no one has explained it. Einstein just assumed the speed of light is a constant for all observers, even ones close to the speed of light. But why? Where, that's nice. Why? Let's hear this again before he came to this wonderful conclusion. You need to come up with a theoretical model that gives you the prediction that the speed of light is a constant. I can do that. I mean, it's too late for me now because we know the speed of light is a constant. At least I can explain it. But based on my model, I can make many predictions.
What did it all mean? Einstein says this another experiment shows that there's nothing wrong with electromagnetism. Maxwell was good. So there's nothing wrong with electromagnetism, and we believe in Newtonian relativity. That cannot be broken. So there's only one way to put this all together. If light does indeed travel at the speed of light, and constant velocity motion should be undetectable, there's only one logical conclusion: the speed of light should be the same for all observers, even the ones traveling close to the speed of light. That's how Einstein came up with this postulate. Does it make sense now?
What does it mean, postulate? What is this word postulate? That's like, is that another word for an assumption? Postulate. What are all these words? Like axiom, assumption, conjecture, postulate. To assume here. Can you see this? Let me show you. So postulate, transitive verb to assume or assert. Oh, wonderful. So it's just an assumption. Just wonderful. Just it's an axiom. Just another word for an axiom. Just another lie that we tell. Great. Just another lie. To assume or assert the truth, reality, or necessity of, especially as a basis of an argument. Wonderful. To propose as a hypothesis or explanation. To assume, oh my god, my eyes. To assume as a premise or axiom, take for granted. So it's just a lie. Wonderful. That's how he came to this postulate. You don't come to a postulate, you don't come to an assumption, Mr. Mahesh. You don't arrive at a postulate. There's no such thing. You don't come to an assumption. And therefore I came to an assumption that's not even that's improper. You don't arrive at an assumption. You start from an assumption. You start from an axiom. You don't come to a postulate. Jesus Christ.
Observers, even the ones traveling close to the speed of light. That's how Einstein came up with this postulate. Does it make sense now?
That's how he came up with this postulate. You don't have a reason to come up with a postulate. You just come with it. What do you mean that's why? There's no why. Like if there is a why, then you have a theory. You know what's causing it. That's fantastic. Tell us, Mahesh, what is causing the speed of light to be a constant for all observers? Is it because there's no medium? What? The because you make no sense, because you make no sense. Now, on top of making no sense, you're also going to create a theory from the nose based on the nonsense, literal nonsense. I can't believe I'm attacking Einstein and Mahesh is in my crosshair. Oh my god. 53 minutes. Anyway, let's continue. We're not going to finish.
Should be undetectable. There's only one logical conclusion: the speed of light should be the same for all observers, even the ones.
What do you mean should be the same? Why should it be the same? What's causing it? Why are you not telling me? Why are you coming to this conclusion?
Traveling close to the speed of light. That's how Einstein came up with this postulate. Does it make sense now? Do you see the motivation behind it? The very reason.
It makes sense? There's no sense. There's no sense. It's nonsense and it makes sense. There's no sense. No one ever claimed there's sense. I can tell you the sense. I have a theory why the speed of light is a constant, or at least is observed to be constant. I can tell you, but you can't. Einstein couldn't. No one could.
Reason he had to do this because it was the only logical conclusion. Because that's the only
No, no. It's not even the definition of a postulate, and it's the assumption that Einstein made. And based on this assumption, he built everything else. He didn't build the assumption based on something else, except for maybe he noticed Michelson and Morley. But that's just, he just took the data. But he never explained it. He took the data and went and ran with it, which is I guess it's okay. I mean, you can, but that's not. You're not supposed to do that in science. In science, you're supposed to notice a phenomenon and try and explain it. And if you can't, at least you say, "Look, we tried, we couldn't." Let's at least put a what do you call it? Um, there, we'll circle back to it. Put a pin in it. Let's put a pin in it. We need to come back to this. At least say that. But what you're saying right now is, oh, and that's the explanation. Oh, now it all makes sense. No, no, it never made sense. It was never answered. This bothered me for. It bothered me that I didn't know what's bothering me for such a long time. This was never answered. It was just assumed. Einstein just said, all right, let's assume and see where that gets us. And it got him pretty far, but he skipped a step. I'm not saying it's wrong. I'm just saying, obviously, it's not wrong because Michelson and Morley discovered it. It's empiric. So I'm not going to argue with the data, but give me the explanation. You're skipping a step and you just say, yeah, let's assume that and let's continue evolving. But let's see what predictions we can make because of that. That's fine. But you're missing the fundamentals. So don't be surprised if you end up confusing yourself and continue until all physics breaks down as we see today. Today it's completely broken. You see physicists, what they're talking about, like alternate universes, infinite universes. Yeah, nonsense. Physicists today have gone off the deep end. They are nuts, and I'm not the first one to say this. So I don't want to continue too long. Okay, 57. We have 2 more minutes. Okay.
only way constant velocity motion can be undetectable and light can still travel in vacuum. Isn't that amazing? But I say Einstein, that's
What? What? I don't know. I don't honestly. I don't know what he's saying. It's undetectable. What?
Does it make sense now? Can you see the motivation behind it? The very reason he had to do this because it was the only logical conclusion. Because that's the only way constant velocity motion can be undetectable and light can still travel in.
Let's slow this down. I can't understand his words. Normal speed and give me the subtitles.
Vacuum. The only logical conclusion. Because that's the only way constant velocity motion can be undetectable.
It's the only way constant velocity motion can be undetectable? Oh, sure. Okay, now I understand. So, constant. Right. So basically, Michelson and Morley discovered that motion is undetectable. Constant velocity, yeah, but this comes out of Michelson and Morley. According to Michelson and Morley, right? They try to discover some some way to know which way are we going in an absolute sense or relative to the ether, and they couldn't find it. So it's impossible to tell where we're going relative to the ether. Constant velocity motion is undefined. If you don't tell me relative to what, Mahesh, it doesn't, that word velocity is undefined by itself. It's undefined. It has no meaning, Mahesh. You teach this. There is no velocity unless you tell me relative to. Now you took away the ether. So you now tell me what is the question? Relative to what? So it's undefined. I mean, for you, it's definitely, I mean, for you, it's undefined. It's not undetectable. It's undefined. There's no need to go and detect it if it's undefined. But you mean relative to the ether, but you don't want to say ether. Anyway, maybe he'll hear it. Okay, I don't want to go over an hour. We're 59 minutes. Maybe what should we do? Should we continue this? Yeah, we'll continue this or something else in another video. Let's stop here. I think you've heard enough. All right, everyone. Bye bye.